Hi guys, Sam here from Sodor Appreciation Society. This week we'll be focusing on Turntable Board and what makes it work, what components we use, where we got them from, and a bit of tinkering and showing you how it works. So here we have the Turntable Board. Connection here goes on to the coal hopper board, which we went through on our first week going through electronics. Turntable itself with Percy on, and then the corresponding sidings. We do have a lovely roundhouse sitting on this that Richard scratch built, and you'll see that if you visit one of our exhibitions or our website. There's pictures on there. This week also the show hooked up to the tablet as opposed to the main TV. We used two of these on Sodor in Duck Branch. When at exhibitions, one is used for controlling, and the other one is used as a short display showing information about us for you fine people to look at. So an example, this is iTrain. Shows currently what's going on in the layout. The turntable here is set into its default position, which you will find on the power on, which we'll go through just now. When we plug the cable in for this turntable board, it automatically provides power to the Arduino and the motor shields that power this, including the stepper motor. So as with every other board that we use, a serial cable comes from the underneath of the board, which we'll go into in a bit, and then goes to the main control box, which is just here. So I'll just plug that into there. You'll notice that the board, the turntable, will then start to move. Incidentally, it found its home position there. We'll do that one again. Take it out, put it back in, and it will then start searching for its home position. It achieves this by using a magnet underneath, which is then fed back to a sensor correspondingly. We'll just wait for that to load up. When we choose to or want it to go to a different siding, there's a configuration for each siding, just the amount of motor steps that it has to move, which means that it's pinpoint accuracy every time. So you'll notice just here we've got that lined up nicely to the main one. If we wanted to, on iTrain, say we want to go into the first siding just here, we're just going to tap that, and then consequently the turntable moves around to the first siding. On the coal hopper board, we went through a blue button that instantly moves the turntable all the way around. That button on the coal hopper board is linked to this blue button just here. So whenever your user presses it, it then interacts with iTrain. So we're just going to press that now as if we were pushing that blue button. And you'll notice that the turntable will start moving in just a moment. There we go. So in this example, it does a full loop round. Great way for kids and adults to see it working without having to have any physical train movement on it, as they just did a full half loop there. If you send it back by pressing the same button, it will do again another loop. You can see on the turntable we do normally have some fencing that goes on here. This was taken off a recent reprint on the 3D printer, and that's some great work. As with the other boards, you've got holes here and all the way around for lights that we plug in, and then you've got various holes in here for struts for the engine shed. You'll notice also here, this is for a smoke outlet that's been covered up and painted. Smoke sprays either side, hence the hole just underneath there. Gives a great effect by an engine in the engine shed. So this is the underneath of the board. Various different things going on here. A lot of it is the same to all the other boards that we have. So you've got main terminal block coming in for the serial cable. You've then got this red block here, which is one of the custom supports we have for the legs that interact with the other board. Leg just slots in there nicely, and then using various clips across the board, it locks it into place. You'll be familiar with the terminal blocks we're using all the way through. Again, you've got your black for negative and your green for feedback, your positive for DCC, along with your grey and brown for your 5 volts, and then your purple and white for your 12 volts. Similar to other boards as well, you've got the smoke housing just here, where smoke unit fits on, which we went through last week, there and there. And then we've also got your plug and play lamps. We also on this board have a isolation switch mounted just underneath. The reason for this is a lot of the locos we have at the moment are only DC fitted, whereas this board is wired for DCC. So if at any point we're using the turntable board just for show, which does to happen, and have DC locos fitted on it, we disable the DCC. It just stops all the humming and interference on the engines and ultimately causing damage. So the turntable is this just here. We got this from an online seller after doing a bit of googling, and the link will be put underneath for that. He has been particularly helpful in helping supporting setting this up, and also issued a replacement when we had a failure. Promptly I will add as well. So it's made up of a couple of parts. You got your stepper motor just here, which is what does the turning in a precise fashion. You then got a custom made acrylic panel just here, which houses it and mounts it, along with obviously your bolts and screws. And then you've got the electronics behind it. So this custom PCB consists of an Arduino Nano, your DCC interface, which interacts between your Arduino and your DCC feed, and then also a couple of stepper motor controllers on it as well, which obviously control the big stepper motor just here, along with voltage regulations. The whole unit it interacts and has to be customized by the Arduino IDE via a computer, and that's where you put your specific measurements in for it to turn, which we'll go through in just a moment. So here's the Arduino IDE open on the main computer at the moment, with the configuration file for the Arduino, which controls the turntable. A lot of code here. Some people will be familiar with this, some people won't. I've had to have a bit of a learning curve into it. However, a lot of it is irrelevant for what we need. As guided by DCC interface, which is the people we got this from, we scroll all the way down to this. This is our positioning just here. So you have your top one, this is home. That gives the exact position and offset that we need for the turntable to line up to the track, and then corresponding to every other point we have, or every other side in we have on the board. Always have to make sure it adds up. It does take a lot of tinkering, but with the help of a couple of other people, for patience more than anything else, you get there in a day or two. That's the end of this week's short video. We aim to get this all together and show it all implemented and working as soon as we can get back to the home where it's stored in Chesterfield. Next week will be a slightly different week. We'll go through a bit more detail in the Arduino and how we can implement that, and how we are implementing that into our own electronics, and how we're taking that forward in terms of being able to sell the ideas and hopefully help fellow modelers like yourself. As Richard touched upon last week, please do follow us and subscribe to us on Facebook, Twitter, YouTube, and give us a visit on our website, which is www.sas-railway.org. Take care, stay safe.